Hi, I'm Emma, and my research project is about the science behind animation. And my research question is, how does knowledge of inertia, momentum, gravity, and weight help artists animate a scene, and what does this accomplish? So after researching my sub-questions, I learned more than what I had learned at first in my physics class. I specifically learned what inertia, momentum, gravity, and weight was, and I realized that they are all part of Newton's laws of motion. I also learned that the 12 principles of animation, about half of them are basically from each law of motion. I really love researching all about this topic since I want to pursue animation as my career, and it will really help me in my future. At first, I knew that there was some physics behind the making of a film, but I did not know that almost half of the work to create a film requires knowledge of physics. For many that believe that animation is easy because it's an art, it's more than just an art, it's also a science. It includes numerous parts of physics such as Newton's laws of motion and force. And my sub-questions are, what is inertia? What is momentum? What is gravity? What is weight? What aspects of force and laws of motion are used in animation? How is physics used in animation? What is the product of an animation? And lastly, what are Newton's laws of motion? So my first slide is just explaining what Newton's laws of motion are, since it'll help with the rest of my project since I reference it a lot. So the first law is every object stays at rest or in a straight line unless something changes its state by another force onto it. The second law is force is equal to the change in momentum per change in time. When the mass is constant, force equals mass times acceleration. And the third law, for every action there is an equal and opposite reaction. So first is inertia. And inertia is something that opposes any force acted on it that is trying to put it in motion or change the magnitude or direction of its velocity. An object will either continue moving or stay at rest if there is no force acted upon it. Basically, it means that an object will move at a constant velocity if there is no force acting upon it. And animators call this technique follow-through or overlapping action. And in this image here, when an object is moved by a force, the dependent object, the flower, will continue to move at a constant velocity. So the force is on the pot, and there is no opposing force on the flower, so the flower will continue moving. And in this image down here, when the artist moves the girl's hair, it makes it seem like there is no force acted upon her. Without the use of follow-through, it seems like something is pushing down on her. So on the without side of the image, it looks like something is pushing down on her and like there's weight from her hair. And on the with side, she looks like she's freely jumping through the air with no forces acting upon her. And with these two images here of the man, due to the law of inertia, the man in the image will continue moving at a constant velocity unless an opposing force stops him. So on the image on the left, the bus is moving forward and stops, and since there's no opposing force keeping him with the bus, he moves forward. And on the image on the right, when the bus is moving backwards and it stops, he continues moving backwards. And another part of the law of inertia is centrifugal force. Centrifugal force is the same as inertia, but in a circular or turning motion. When a car makes a left turn, the person's body will move towards the outside or to the right, because there is no force pulling the person into the left. The seat belt is supposed to act as a force keeping you moving with the vehicle being the object of opposing force. And for example, here is an image of how that works down here. Next is momentum, and momentum is the amount of motion that is built up in any moving object, which is solved by multiplying the mass and velocity of it. An artist uses a technique called anticipation, where the character being animated builds up momentum so it can appeal to the eye and seem realistic, just as any object would have to do if they were going to do something fast. And to understand how to do this, they study Newton's second law of motion, and which states again that the time and change of momentum is equal to the force onto the particle or object, and this law also correlates to acceleration, which is made by the momentum. And in this image here, with the use of momentum, it makes the punch look stronger and of course more realistic to a normal punch, and as you see in the bottom one without anticipation, it looks very weak. And Newton's second law also states the law of gravitation, which also accounts to how animators know the rate at which an object falls and how it grows to be faster and faster the closer it reaches the ground. And how to solve for the law of gravitation, one needs the mass of both the Earth and the object, the gravitational force between the two objects, which is the gravitational constant, then the distance between the center of the objects. And more about this is on the weight and gravity slide that I'll talk in a bit. And Newton's cradle is a great example of conservation of momentum. The momentum acted on the object will carry through to the end of the collided objects, and as seen in the cradle, the momentum carries through the collided objects. And in the image of these two balls here, the momentum of the larger object is small and the momentum of the smaller object is bigger. When they collide, the momentum carries through and transfers to the other object. This also connects to Newton's third law. Lastly, weight and gravity. Weight is equal to mass multiplied by gravity, pretty much is the quantity of the gravitational pull, and gravity is the force that pulls objects together. When a ball bounces on the ground, it loses speed due to energy that is lost. The more it hits the ground, the more it will lose energy, thus making it slowly get closer to the ground then stop. Every falling object also has an acceleration due to gravity that is 9.8 meters per second squared. When the ball is about to bounce back up, there is a negative acceleration opposing the force of gravity. Mass does not matter in a free fall. When an object is in free fall, it will continuously become faster when going towards the ground. Even if it's launched at an angle, it will always go towards the ground faster and faster. Here's a diagram showing how that works. Even if there is an angled object versus a normal free fall, they will both land on the ground at the same time. And animators also use a technique called squash and stretch when animating a bouncing, jumping, or running object. Now, all this information helps animators because it can make an object bouncing look realistic and not fake to the human eye. And for example, these two balls, there's one without squash and stretch and there is one with. The one without doesn't have any character to it and it doesn't look realistic at all. But with the one with squash and stretch, it looks completely realistic to where it goes faster once it reaches the ground and also expands. And when the object does not follow the principles of weight and gravity, it does not appeal to the viewer and it has no emotion. Animators also like to exaggerate their sequence, as seen in the ball bouncing when it hits the ground. Exaggeration is another animation technique, and here's another example of how another object, other than a ball, has squash and stretch with a cat. So here are the 12 principles of animation that you've heard me said numerous times before, which were created by Walt Disney. First is squash and stretch. Second is anticipation. 3 is staging. 4 is straight ahead action, pose to pose. 5 is follow through and overlapping action. 6 is slow in and slow out. 7 is arc. 8 is secondary action. 9 is timing. 10 is exaggeration. 11 is solid drawing. And 12 is appeal. And numbers 1, 2, 5, 7, and 8, squash and stretch, anticipation, follow through and overlapping action, arc, and secondary action all apply to physics. And every principle that has to do with physics is all about Newton's laws of motion. They are exactly like inertia, momentum, gravity, and weight, just with a different name. And here are the 12 principles of animation, and I'll list off the ones that are part of physics. Squash and stretch is squashing and stretching an object or character to give the illusion of weight. Anticipation is preparation for an action. Follow through and overlapping action is loose parts of the body continue moving after the character stops and eventually catch up. Arc is actions should follow an arc to give them a better flow, basically what it is. And secondary action is a second action in the scene to complement the main action. So if one object does this, the other action will also apply to it. And lastly, here's the answer to my research question. And after learning how inertia, momentum, gravity, and weight all to go together, in an animation, we should realize that all of those concepts are in stages of building a scene in animation. So inertia is the process called follow-through, and momentum is the process called anticipation, and gravity and weight help with the process of squash and stretch. And all the rest of the physics-based steps are all basic knowledge of physics. Objects fall in an arc shape when thrown up at an angle, and another object is affected by another's action called secondary action. And overall, these help the animator create and accomplish a finished, realistic, physically correct film. So now that you know about all these aspects of physics, animators can then put into a scene. With Thumper here in the beginning, he builds up momentum and acceleration to go over this frozen lake, and if that didn't happen, then he wouldn't be able to go as far. And with Snow White here, her dress has centrifugal force and follow-through, which is inertia, and the dwarves have exaggeration, which is weight, which is why they keep going down whenever they bounce. And Ariel here, she has follow-through and exaggeration. And animators also have to keep with the atmosphere, so that's why her hair is so flowy. And lastly, thank y'all for listening to this project, and I had a really fun time doing it, and I hope y'all learned something also.